All right, so we're going to talk about the graphs of exponential functions. So let's start off and just say that we're going to let f of x equal b to the x. All right, if that's the case, what is f of 0? B to the 0, which is 1. That's going to be the y-intercept. So regardless if it's exponential growth or exponential decay, as long as there's not any shifting upward or left and right, there's no shifting, then that should be your y-intercept. All right, let's say we put in 1 for x. Find f of 1. What should that be? Should just be b. Yeah, should be whatever b is. Oh, sorry, that's wrong. That should be 1. All right, if b is bigger than 1, it's going to end up being exponential growth. And then if b is less than 1, it's going to end up being exponential decay. Right? Both of these graphs, sorry, I'll get caught up. So both of these graphs have the same domain. So if you have an arrow pointing to the right and you have an arrow pointing to the left, what should your domain be? All real numbers. So there is no restrictions on what the exponent can be. It can be anything. But there are restrictions on what the y can be. Because we said before, I think, that there's not a number that, if it was 2 as the base, there's not a number you can raise to 2 and it ever be negative. And there's also not a number you can raise to 2 and it ever be 0. So, bless you. The range, if there's no shifting up or down, is that y value has to be greater than 0. It's never going to get to 0. It's never going to be less than 0. And then all exponential functions have a horizontal asymptote. And it really pretty much lines up with whatever the range is. If there's no shifting up or down, then that horizontal asymptote is going to be where y equals 0. And then, of course, transformations affect everything, really. The y-intercept, the range, and the horizontal asymptote. Do you think a transformation is going to affect the domain?
No,
the domain's going to stay all real numbers no matter what, but all the other things can change from problem to problem. Okay. So we're going to do some transformation questions. I hope you guys remember some stuff about transformations. So we're going to say on number 1 that the parent function is y equals 2 to the x, and it's reflected across the y-axis and vertically shrunk by a factor of 1/3. And we're going to write the resulting. So to reflect across the y-axis, there's going to be a negative. Is it going to be inside or outside for the y?
Inside. Yep.
So we called it the yin side, if you guys remember. So there's going to be a negative on the inside, or the yin side, to make it reflect. And then what about this vertical shrinking? You're going to multiply inside or outside? Outside. Anything vertical is outside. Anything horizontal is inside. Okay, so we have a brand new function. I just want to call it something else. So I'm going to call it f of x. All right, I know we have 2 because the base has to stay like the parent function base. And then to reflect on the y-axis, it's going to raise it to the negative x. And then to vertically shrink by a factor of 1/3, it's going to get multiplied by 1/3 on the outside. And that's it. All right, let's look at number 2. So we have g. First, we're going to give the parent function. So the parent function is the most basic function. So if you just shed off all of the addition and subtraction and multiplication or negatives, if there are those, what are you left with in this problem? 2 to the x. That's the parent function. All right. This has 2 transformations. We have that, and we have that. All right, so adding 1 on the inside, what is that going to do? Shift left 1. Good. All right. I don't think I have this green color. What about that adding 6 on the outside? Good. That's it. All right. What do you guys think about the domain of G? Should it change from the original parent? No. It's just going to be all real numbers. Okay. So basically what happened on this one is this was to the x that we did earlier. It shifted to the left 1 and then up 6. So how is that going to change the range?
We start with 6, right?
Right. So instead of y is greater than 0, it's going to be y is greater than 6. Good job. Right. And then to find the y-intercept of every function in the entire world, you put 0 in for x. Right. And then 2 to the 0 plus 1 is just 2 to the 1, which is 2. And then whenever you add 6 to that, it's just going to be 8. That's going to be where it would cross the y-axis. Right. And then all exponential functions have a horizontal asymptote. And if you've already figured out what the range is, all you have to do is just change the greater than to an equal sign, and that's going to be the horizontal asymptote. But the horizontal asymptote of the original one was shifted up 6. So this number right here, whatever is added or subtracted, always gives you the horizontal asymptote. And if there's nothing that's been added or subtracted, then that horizontal asymptote is 0. It's not this time. It's going to be 6. So y equals 6 should be the horizontal asymptote. Okay, a couple more. These two, the number 3 doesn't take too long. All right, so we have this exponential function where we don't know what the numbers are. There's no scale. But would you say this is growth or decay?
Okay.
This is decay. So that means that base needs to be between 0 and 1. All right, and then C is where the horizontal asymptote is. Would you say that is positive or negative? Negative. So C is going to be less than 0. So which choice do you think must be true? Pretty sure we just wrote it. D, yeah.
Ah, crazy.
Sorry, it took a while to see it. It's okay. Okay, and then number 4 is kind of like the last one we did on the other side. So back with your car sort, this is what G was. And we're going to write an alternate equation that instead of shifting right 1, is going to be some kind of vertical dilation or vertical stretch or shrink. So what happened to do that is working backwards. We started off with 2 bases of 2, where when we added the exponents, I ended up with x minus 1. So what do my 2 exponents need to be? X and negative 1. Very good. All right. So what is 2 to the negative 1?
Oh.
1 over 2. Good job. Is multiplying by 1/2 going to be a vertical stretch or shrink? Or vertical dilation? Yes. All right, we're not going to do the proving part. That's okay with y'all. I could if you want. If you really want me to, I can. It says to prove that the 2 equations are equivalent. I don't want to do that. Unless you guys want to see it.
I believe you. Let's see it.
You want to see it?
Let's see it. Okay. I got it.
I feel like the proof is just the same thing as what we just did. Oh, okay. So 1/2, that's going to be 2 to the negative 1. 2 to the negative 1 times 2 to the x. We just add those exponents, and that's it.
For sure.
No big deal. All right.